Video is 2.6 extension, very similar to 2.6 writing equations, but now we're going to focus on writing equations dealing with parallel and perpendicular lines. Write that down, pause if needed, and I'm going to jump right into the first example. First example says write an equation on a line that passes through this point, so we have a point, and is parallel to this line. Well, lines that are parallel have the same slope, so we will use -3 for the slope. I have a point, I have the slope. I cannot use the point slope equation because my point isn't 0, 2. So that's out. I will use the point slope. So y minus, this is x, this is y, 2 equals my slope is -3 times the quantity x minus 1. And if they didn't require you to graph this or find the y-intercept, you can stop here. If you continue, you would have it in the slope-intercept form. Add 2 to both sides, leaving you with y equals -3x plus 5. Same slope, that's good. Passing through 0, 5 instead of 0, 4. And also passing through 1, 2. Next equation is I'm moving it over, whoops, sorry. Let's just make that a little smaller. So, it says to write an equation of a line that passes through 0, 7, so we're given the point. And that is parallel to this line, y equals 1/2 x minus 4. So parallel lines have the same slope. And write an equation. We have two choices. We can use the point slope like the previous example or the y-intercept. I'm going to use the y-intercept because y-intercept is when x is 0. So y equals, put your slope in, add your y-intercept, which is 7. It crosses the y-axis at 7, and you are done. This crosses 0, 7, and has the slope of 1/2. This crosses the y-axis as -4, same slope. Next one is dealing with perpendicular lines. It says write an equation of the line that passes through -1, 1 and is perpendicular to the line shown in the graph. So we do have a point. Unfortunately, it's -1, 1. It's not the y-intercept. And we can get the slope. The slope of perpendicular lines are negative reciprocals of each other. So let's find this slope first. So the rise is 2, as you can see, and the run is 1, 2, 3, 4. 2 over 4. The rise again is 2, 2, 3, 4. Just checking. And the slope reduced would be 1/2. So we need to take the reciprocal of this, would be 2 over 1, and then the negative. So when I multiply these two, remember I would get -1. The product would be -1. So perpendicular slope would be take the reciprocal and take the opposite. So we have the slope of -2. I'm going to use the point slope because I don't have the y-intercept for my new equation of the line. Y minus, and again, this is your x, this is your y. Y minus 1 equals, the slope is -2 times x minus a -1. Clean it up, y minus 1 equals -2 times x plus 1. And if you're curious about where this line would cross the y-axis, you could, that's the reason you would continue to simplify or solve for y. Y minus 1 equals -2x minus 2. I'm distributing. Add 1 to both sides. So y equals, where am I? -2x minus 1. So it goes through -1. Same slope, it goes through, not the same slope. It's a negative reciprocal of the slope. So sorry about that. So it goes through -1 and kind of like that because the lines would be perpendicular. Example 4. Let me scoot it over a little bit. Write an equation of a line that passes through -3, 1 and is perpendicular to the given line. So we have a point. It's not the y-intercept. We have a slope of -5, so I have to take the reciprocal, which would be 1 over 5. And because this was negative, perpendicular slope would be positive. So m equals 1/5. And just so you know, this is the x, this is the y, just so I don't make a mistake. Y minus 1 equals, my slope is 1/5 times the quantity x minus a -3. Y minus 1 equals 1/5 x plus 3. And we're done with that one. And 2 for you. Write an equation of a line that passes through 2, -5 and is parallel. And then the second one, obviously, perpendicular. You are not given the y-intercepts for the new equation. So you cannot use -2. You cannot use -4. That's for the equation we're using that has the slope. That wraps it up for 2-6 extension.